AAS, side angle side, we looked at hypotenuse leg. If you remember our little triangle lab, we also learned about, well, ASA, angle side, angle postulate here. So if we have two angles, here's my angles, right? And the included side. So again, what does that mean to be the included side? What does that mean? In between them. So angle, side, angle. You kind of have to be able to say it in the order that you're kind of working it in your triangle. Angle, side, angle. Is this postulate here? It must be the included side or you're not doing angle, side, angle. So here's an example. Can we prove triangle PQR congruent to RSP? So let's mark our triangles here. We've got PQR, and we've also got, oops, RSP, so these two. And what do I know? I've got this angle congruent to that angle. I've got this angle over here congruent to that angle. So I've got two angles congruent. What else do I have here? What else? Yeah. So PR is going to be congruent to RP because they are the same line reflexive property. So yes, we can. What are we going to use? Angle, side, angle. Angle, side, angle. So using angle, side, angle, I can also prove that these triangles are congruent. So we're just looking for that pattern. The other one we have angle, angle, side. So this is two angles and a non-included side. So you've got an angle, another angle congruent. Now look how this side is not included. So when you read off in order, you're going to say angle, angle, side. Angle, angle, side. This is not angle, side, angle. So be really careful how you read through. It has to kind of follow. Can I say side, angle, angle? Yes. Yes, you can. But say them in the order that you're seeing them. In the order that you're seeing them. So not the included side. If it is the included side, that's angle, side, angle, because that's the order they would be appearing. All right. So an example here. Oh, we've got a whole proof. Let's see what's going on here. Angle A congruent to angle D, angle C congruent to angle F, and we've got B, C, and E, F. So my triangle is marked here. So these are my givens. Angle B is congruent to angle E. Why? Why is that? How come? Why is that?
You have two angles and
Yeah, two angles in a triangle are congruent. What must be true? And the third one. I think what do we call that? The third angle congruence rule or something? It has a name. I can't remember the names. I can remember what it is. So that's why I wrote it that way. Great. How come now I can say the triangles are congruent? How come? What do you see in the picture?
all the angles, all the corresponding angles.
But that's not enough, right? Is AAA enough to prove congruent? No. Do you see something? Angle, what was that we're proving? We're proving angle, angle, side, but you're on the right track. What do you see? Angle, side, angle. Angle, side, angle. Since that one is a postulate, we're not proving that one. So we prove what we can, and this one we can. We're going to use angle, side, angle to prove angle, angle, side. Here we go. So this one for sure we know works great. Here's an example of one. Can we prove these two triangles congruent? Let's see, what am I given? S is congruent to U. And I've got RS congruent to VU. What can I do? What can I do? RTS, yeah. And VTU. Why are they congruent again? Vertical angles are congruent. So what? Now what? Why can I come to my conclusion now? Angle, angle, side. Yes, we can, right? Good. So you're using stuff just because we learned it, you know, that was last month. We don't have to know that now. Everything is building on top of everything else. Let's see. So now we're just kind of looking at different triangles here. And this one here, this is like A on your paper here. Can we use the different things that we know to prove a triangle that is congruent or not congruent, right? So So I've got two triangles here. Can I prove them congruent? Can I?
Yes, because vertical angles are congruent.
Okay, so I got these, right?
Yeah. So
Okay.
angle side angle.
Angle, side, angle. I like how you said that. Angle, side, angle. Say them in the order that we see them. Great. How about this guy? Can we tell anything about, you kind of, which two triangles, this one and this one, are they congruent? We have enough information. What do you think? What do you think? No? Why not? Okay, absolutely. Right. Well, it could, right, it could be one like a miniature version of the other. Remember angle, 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 you can have two triangles that have all the same angle measures, but their proportions are different. So, I don't think you can, no. Why not? Because angle, angle, angle is insufficient to prove congruence. Maybe they are, but we can't prove it. So angle, angle, angle is insufficient to prove congruence. So I'm going to say, yeah, I don't see how this could be. I can't assert it powerfully. Let's look at the next example here. Here's two triangles. Are these things congruent? What do you think, Maria? Yes, you're very tentative. Why? Yeah, it looks like we got an angle, angle, side, angle, angle, side. So one's kind of a flip of the other, but that's okay. They're still the same size, same shape. They're still congruent. And I do see angle, angle, side. I like that she said it that way. She's reading it in the order that you see it. Right? This one is not angle, side, angle. How about this guy? Oh, are these things congruent? Anything, Andrew?
Yes.
Why? Hinge? What's that? You think about the hinge theorem? The hinge theorem, we're using that with triangle inequality, right? So how are you using that here? I want to know. You've got an idea here. I want to hear it. What do you mean by that? I need more than hinge. Well, how are you using the hinge theorem? You're not sure. You're not sure. What do you think, Thomas? So? Yes, why? I don't know. Why? Angle, side, angle. I've got an angle, I've got a side, I've got an angle, and I've got the matching angle, side, angle. So, just, did anybody want it to be hypotenuse leg? It's a right triangle, right? But it's not hypotenuse leg. I don't know anything about the hypotenuse. If I did know those hypotenuse, is that how you say it, John? Hypotenuse, I don't know. But if they were congruent, I could have used hypotenuse leg. But I know angle, side, angle. I only need one theorem here. How about these guys? I have to go upside down a little bit. But let's see, are these congruent? What do you think? What do you think? Angle, angle, side. Let's make sure. So we've got the one arc, the two arcs, and then the line. The one arc, the two arcs, and then the line. Because sometimes they'll do tricky stuff. They'll turn it upside down and they'll give you this one and not that one. So you have to be really careful. For angle, angle, side, make sure they're corresponding sides that are matching. And it looks like they are here. So this is angle, angle, side. Yeah? What else we got? Congruent triangles here. Anybody on there? They're standing on their toes. What's going on here? Are they? What do you think?
There's not, because side, angle, you can't use that one.
Oh, okay, so the corresponding sides match, but it's side, angle. Side, angle is insufficient to prove congruence. How are we going to remember that? Remember that side angle doesn't work? Because donkeys don't work? Yes? You could, but that doesn't work either. Right, we can't, if you have a side and an angle in that order, because remember we did this, and it could be, this side could swing over. So you could have like another triangle with the same length, but that side swung over. So it's just insufficient for us to know that those two triangles are congruent. So I can't make that conclusion. All right, a little proof here. Proof. Angle PQS. So PQS, and it is already marked because this one. But I always mark them again because I kind of need to just feel that and see it. Can I prove that these two triangles are congruent to each other? Can I? Answer that question first. Can I? What do you think, Asa?
Yes.
Yes. How come? Before we write anything, how can we make this work?
The middle line.
Right? So what have I got here? Angle, side, angle. So that's your planning for your proof. You have to think of that first. All right, so to prove it, whisper, you guys okay? Yeah. All right, so first let's just write down our givens. That seems like the easiest way to start. Because we're flying without a net here. Nobody's giving me anything. Just go ahead and prove it. Go ahead. All right, now, Asa told me that this is congruent to itself because of the reflexive property. So QS congruent to QS. Reflexive property of congruence. And I'm ready for my conclusion. Because I have to show one of those congruence theorems or postulate, and I did. We showed angle, side, angle. So 3 steps, that's all it took. That's not so bad. Not bad for proof. Is it? Correct answer to that question. All right, let's try this other one. Oh, this one was too hard. KLN is congruent to angle MNL, so that's this one congruent to that one. And these are parallel lines. Nice. Okay, can I prove the two triangles are congruent? How do I do that? What do I do?
Middle line again.
I'm going to get a nice reflexive. So what do I have so far? An angle and a side. Okay. So I need either an angle, side angle, or I can do a side angle, angle. Depends which one I can get. Can I get any angles congruent? Yes. Which one? Well, we have to, N is ambiguous. So K and L is going to be congruent to what? M, L, N. Because what? Why are those going to be congruent? Why are they congruent? Look at, here's my parallel lines. Am I making like a Z shape? You can make a Z shape, and in those corners you can tuck an angle. Which angles are those? Which ones are those? The alternate interior angles. So because those lines are parallel, the alternate interior angles are parallel, and look what I got. Side angle side. So we have to write all that down, yes. So KLN is congruent to MNL. Given. I'm writing it in a slightly different order. Just because I'm writing it one way doesn't mean that you have to. I'm going to say now that the NL is congruent to LN by the reflexive property. Oops. Reflexive. Because I'm working, I've got my angle, I've got my side. Now I'm going to show the other angle. Angle K and L congruent to angle MLN. I think I said that right. Alternate interior angles of parallel lines are congruent. So let's see, there's my angle, there's my side, there's my angle. So I'm ready to say, yep, I have reached my conclusion. They are congruent, these two triangles, because of the angle, side, angle postulate there. So is that horrible? Now, can I put these, all the, I forgot my parallel? Oh. I didn't put that in here. I forgot to say they're parallel. I could have put that step in here. say they're parallel with another given. I could have done that just to kind of be very orderly. So you try this little proof here, on here, you try, start from scratch, right? I'm not giving you any clues. Here's what I'm giving you. I did mark the diagram for you. Now prove the triangles are congruent.